It worked. All right, great. Hey, I'm Tom Sinclair, and this is Streaming Idiots. I am delighted and excited that you could join us today. If you're watching us on Facebook or Twitter or Periscope or even YouTube directly, I would invite you to come on over to easternshorebroadcasting.com where you can get in on the chat room where I don't even want to tell you what they're chatting about right now. There's no telling what that group's, but there are a bunch of them over there and they're having a big time. And I want to appreciate all of you. I do appreciate all of you that have come in live for the show today. Live is always so much more fun. But if you're watching us later on YouTube or Facebook or Periscope, we'd love to have you come join us live Wednesday afternoons, 3 o'clock Eastern at easternshorebroadcasting.com is the best way to do that. Somebody says, what's behind Tom's head? Don't do that to me while I'm live. Oh, who was that? Gee whiz. That was Giles. Gee whiz, Giles. Yeah, what am I going to do with you? Holy cow. I am really excited about our guest today, Michael Rempel, the professor of audio. The audio professor, we're going to call him, is going to come in and he's going to make your brain explode when he talks about audio. I can't wait. But I had a few things that I wanted to cover before that. One is that, and I haven't announced this anywhere, so you guys are going to be the first to hear it. We did talk a little bit last week about coming up in January, we're going to start our live streaming rookies program. It'll be a 6-week live training class, and we want to polish that a little bit. So anybody that's interested in that before then, we're going to start it next week or the week after at half price. Normally it's $99, but for $49 you can get in on the 6-week training. And we don't have anything up. I mean, this is the epitome of terrible marketing. But if you're interested, shoot me a note, tom@easternshorebroadcasting.com. We're going to do an afternoon session and an evening session. So whichever works out best for you time-wise, you can get in on that. It is limited. It's limited to 12 people. So we don't want a ton of people because we want to have a lot of personal interaction. So it'll be a series of presentations with questions and answers and discussion. It'll be a lot of fun. So, and I got ARAM already on the list. I knew, and that's one of the reasons why I wanted to push it up, because you guys need it now. You don't need to wait till January to do that. Anyway, all right. Oh my gosh, Marie says that they're watching on the big screen in the living room. You guys need to get a life. I mean, that is just too much. The other things that are coming up is, if you are thinking that you might want to go to NAB, the National Association of Broadcasters Conference and Trade Show in Las Vegas in April, you probably need to make your hotel reservations now. I was making mine just the other day, and I saw that my favorite hotel was, not only was it already booked, but its prices were like 30% higher than last year. So I would encourage you to make those reservations. We are going to have a Streaming Idiots meetup at NAB on Tuesday night. Location to be confirmed, but we're hoping, Scott Whitney, that you'll let us use your studio again. That was such a blast last year to actually be in a live streaming studio for a meetup. It was a ton of fun. So put on your calendars for Tuesday, I think that's the 9th or the 10th of April, the Streaming Idiots meetup at NAB. It'll be offsite and it'll be a ton of fun. You will not, if there's an event that you want to go to in live streaming next year, 2018, it's going to be NAB, and it's going to be the Streaming Idiots meetup at NAB. You won't want to miss that. I wanted to make sure I've got all my notes done. Yeah, full disclosure, this is a giant infomercial. Hopefully a lot of info and a little bit of commercial, but here's the commercial. I'm a reseller for vMix and Magewell and Marshall. That's the camera we're using today. And PTZ Optics. We finished up our PTZ Optics group buy. We've got just a little bit of time. So if you're interested in a PTZ Optics camera, we see if we can't squeeze you into the tail end of the group buy. We're closing that up, but we were able to get some really good pricing. So it's really exciting. The other thing that we do, again, this is part of the commercial now, I design and build custom streaming PCs. You say, oh, well, Tom, I don't need a custom. I just need something off the shelf. Well, we have those too. If you go to our website, easternshorebroadcasting.com, you can see some of the more common ones that we have right there. So there we go. What else? Have we covered all the bases? All right, let's talk about audio. Let's talk about audio. Yes. Everybody struggles with audio. Well, not Michael doesn't struggle with audio, but everybody else, except maybe Martin Kay and Mike Phillips, struggle with audio sooner or later. Video is easy because you can see it. It's here, and it's there, and it's there, and it's there. And if it's not right, it's evident. Audio is cover your ears, it's a friggin' mystery. It can be an absolute nightmare. You can have double audio, triple audio. Sometimes if you're really good, you can have quadruple audio, and it's all going at different times at different levels, and who in the world knows where it's coming from? You can control audio on your mixer or your audio interface. Some microphones actually have a volume level on it. You can control audio in Windows. You can control audio in vMix, several different places. And who knows where the problem is? Heaven forbid you're doing something really fancy with audio. Basically, it's like plug a microphone into my PC and let that be. Well, even then, you've got 4 or 5 different pathways that the audio's going through. Not to mention all of the things that audio does in and of itself in terms of the characteristics of audio. And that is what our guest today, Michael Rempel, is going to talk about. He is the audio professor. So, Michael, welcome to the show. Glad to have you here. And we probably ought to do an audio check before we get you going just to make sure I turned your audio on right.
Did you get it?
I got it. Who was it? There was somebody on the show a while back where I did that, and they go, did you get it? And just, I hate that. I hate that. Well, welcome. Thank you so much for taking time out today to come on the show and to teach us about audio. And you and I had a great session yesterday where we sort of ran through what we wanted to talk with. And folks, I'll tell you, Michael's got like 6 months worth of audio stuff, and that's probably still just cutting the surface. Fill us in on your background. Tell us why you are qualified to carry the title that I gave you, the audio professor.
Oh boy.
Yeah.
Okay.
Just some of the highlights. Some of the highlights.
Back when I was 18 years old.
Yeah, that's right.
I was really into music, and I did some touring and went on tour with some of the bands. Got into it a fair bit. Didn't really learn a lot of the theory behind it, and decided that I wanted a real career eventually, and went into programming as software development, but never lost the passion. And I've been doing shows and working with people for years and years. Mixing for concerts, mixing for festivals, and so on. The theoretical aspect of it came in when I started being really interested in designing better sound equipment in the digital era. Because I knew for a fact that in the analog era, we didn't have control over delays. Delay is a very expensive thing to set up the time coherence of a system. I'll get into that later if we want, but that physical attribute was missing from all the analog stuff in the world at that point. I started building a parametric equalizer that had some delay features built in. I started designing pan that doesn't use volume anymore, because normally when you got stereo, you got 2 speakers, and the loudness of one is versus the other is what tells you what the pan is. But in the real world, actually, it's the delay between 2 different sounds arriving at your ears that tells you within about 1 degree where the source is coming from. And so, pan-based delays are actually more accurate. Some of the loudness is in there, but pan is really more delay than it is loudness.
All right, hold on a second. I got to interrupt. You and I made an agreement, and that is that that sometimes you like to get down this road down here.
We went down a long bunny trail just now.
Yes. So I'm going to pull you back.
And we lost a
say,
whole bunch of people doing it.
no. They're just waiting for the meat. They're just waiting for the meat. So, but you have worked on all sorts of really cool projects.
Well, not only in audio,
Right.
but anyway, okay.
Right.
Let's talk about. I have design credits on Avatar, the movie.
Now we're talking.
I have design and new media architecture credits from the Canadian Museum for Human Rights as a senior developer, architect, designer for their system.
Right.
I've done a lot of fairly large, fairly important computer and audio related things over the years. And so I know a little bit. And maybe other people on the chat, so on, know some things I don't know. I don't know. But let's start with some basics about what audio is, what sound is.
Yeah, I'm with you. Come on. I'm just
okay.
I'm playing to the chat room.
Okay.
Yes, give us the basics. And if I need to bring up a chart or a graph or a picture or something, holler.
Okay, so what is sound? We haven't talked about it, but sound is usually depicted as a bunch of waves. But the reality of sound is that it's actually air pressure playing on various things in this space. When you get a sound that's created, say the bang from a gun or something, and you got every frequency in the whole world going off, you hear some of those frequencies just go away immediately, and some of them reverberate,
right,
and sustain for a while. The ones that sustain for a while are sustained by the physical resonances of the room or the space you're in or the space that it occupies. Every thing in the entire universe is actually a resonator in audio. That's a physical property of everything, just like reflecting light is a physical property.
Right.
Okay. So when you're creating sound with something like a violin or a tuba, the violin is usually regarded as a very pure sound, a sine wave, a single frequency, we call it. What are sine waves and what are they good for? What are they useful for? Those are I call them the fundamental building blocks of sound. When you look at the sound spectrum, the way we do as we're analyzing it, I'm trying to make this simple, and to me, these are concepts that I don't think about a lot because they're just there. But to be clear enough, okay, so a sine wave is the fundamental building block of what a sound is. Mm-hmm. And when you get a bunch of them together, they create the characteristic sound. So you get a bunch of frequencies emanating. When I do that, for example, there's a bunch of sine waves that are components of the sound that I just created with my hand.
Right.
We use sine waves in sound because they're mathematically elegant and we can compute with them, not because they're fundamentally better than any other shape. But there it is. That's good. So when we talk about frequencies, we're always talking about sine wave frequencies. And we're always talking about sound being composed of these sine waves at various amplitudes, volumes, and in relationship to one another. So let's be real simple. Tom always likes simple, so we'll talk about one frequency instead of a bunch of them. At one frequency, I told you that the frequency relates to the physical size. How does that work? The physical length of a sound wave is related to the speed of sound.
Right.
Speed of sound is constant. And if you want the magic number, it's 1,125 feet per second.
Yes.
Okay. Or I believe it's 432 meters per second, which means a 1 kilohertz signal is 432 millimeters if you go metric. No math involved. But if you're going, say, 1 millisecond worth of sound, it's going to travel about 13 inches. So all of those, the length of the sound and the frequency of the sound are all related to one another mathematically.
Right.
Okay? So when you know the distance or the size of a thing, you know the frequency. All right?
Okay.
That's, if it's creating it, that's where it creates it, at the sweet spot. And if it's receiving it or bouncing it or dealing with it or playing with it, that's the best way to understand the frequency.
Okay.
And the frequency
is now a good time to talk about where microphones plug into this?
you want to, don't you?
Yes, I do. I want to talk about microphones. And you want to talk about microphones too. Because you've got 60 microphones sitting there in your studio.
Well, yeah, I have a few.
Yeah.
This one is a measurement mic. This one is homemade. This is where I want people to think about sound, not in terms of the brand name or the manufacturer or anything like that, but that is a classic little mic.
Okay, your camera got shifted off to the side. We need to shift.
Where am I here? This is an SM57.
Okay.
And it's a dynamic mic. What's a dynamic mic?
Well, I can answer that question.
Okay, go ahead.
A dynamic mic is a flashlight.
Well, it works that way.
Yeah.
But a dynamic mic could also be an omnidirectional.
Turn your camera back a little bit more towards your right shoulder. Because it got moved.
Oh,
it got moved. It got moved a little bit.
I got some wires that are pulling things here. Sorry.
That's all right. That's good. Yeah, there you go. That's good. That's good.
This is my play shop, okay? Everything is piled on everything, and I don't make any apologies for that. So what's a dynamic mic? When they started off in the golden old days, back in Alexander Graham Bell's day, they put carbon in a little tube, and they put a diaphragm that vibrates on the front of that. And the diaphragm would push on the carbon and change its electrical characteristics, the resistance of the diaphragm. And when you put some voltage through that, then it would then translate that into a wavelength. Now, those are really horrible. The next step they went to was they say, well, okay, let's go with some graphite plates, because those have a more predictable, stable interaction. Some of the old guys on the channel might remember you getting out your headset. Can't hear. Don't listen to this. I'm going to bang the phone. And you bang the phone on the desk. You come back and no, it sounds clear again. Well, that was because all the carbon fibers had managed to settle at the bottom and didn't work anymore.
I have to hit my mic all the time. Yeah, I understand.
The graphite plates helped quite a bit, and that was, that's a classic sound that us old guys all know, because that's the sound of the handset phone,
right? Before
the modern microphones came along. Well, then they came along with these guys. The difference is it still has that wobbly diaphragm, but there's a electric coil at the base of this mic that the wobbly thing vibrates up and down, and it's a little bit better at gathering and keeping the sound properly. I'm not. I was going to take it apart, but this one doesn't come apart that way properly easily. So,
hammer.
Oh no. That's what by the way, that's what the Shure microphone company is famous for. It's not so much that the Shure dynamic mics, this 57 and the 58, are all that good quality. They're not. Never were supposed to be. But the the thing is that they are pretty much indestructible. Then they came along with these guys. This is an old Audio-Technica, and it's been modified internally. And I, did some changes to the electronics. You won't see that; it's in the handle. But I wanted to show you the capsule here. I'll talk to you about how these guys get designed. You can see inside there's some foam in there. That's to stop me from spitting on it so that it doesn't go down in the diaphragm. There's some more foam in here that's also designed to protect the microphone. The capsule itself is way down here at the bottom, the gray thing.
Yeah.
Okay. And this is actually a different kind of mic. This is a condenser.
Uh-huh.
And all the word condenser really means when compared to dynamic is that instead of using passive electronics, where the voltage is kind of generated by the mic and it gets shoved down the wire to go to the speaker.
Right.
This thing actually has active electronics in it that get fed by, you can feed it with a transistor. And usually in these guys, they will also have some equalization, and they will also have a op amp that is driving the output. So it sends a little bit of a stronger signal back to the mixer. Not usually. Strength isn't really what's important there as much as it is a clean signal that nothing can mess with. Because one of the things most people don't know is about frequency-based electronics is that you can push stuff into one of these mics, but you can, as well as, audio from this end, you can push it in, but it can also be pushed out. On the old SM57 I was showing you, if you took a diagram, a circuit diagram of this mic, and compared it to a little speaker, there's no difference.
Uh-huh. That's what they were talking about in chat, that the mic could be used as a speaker. Not that you would ever use it as that, but you could.
Actually, some guys do use about a 4-inch speaker as a kick drum mic.
As a mic? Oh, that's cool. Yeah. So they use a speaker as a mic because it has the same characteristics. Mm-hmm. I like it. All right, so we got condenser mics and we got dynamic mics, and that's kind of our two basic. Am I safe in saying that's kind of two basic categories?
Okay. Yeah.
Thank you.
Let's pull up. There's other ones. There's ribbon mics. There's other things too, but it's all amounts to one of those diaphragmy things vibrating and pushing on something electronic.
Right.
Okay. The magic sauce for a ribbon mic is that it is really good at hearing the sustaining sounds of like a violin, whereas the dynamic and the condenser mics are better at hearing the smack of a drum.
Okay.
So that's impulse response versus sustained response.
Okay. Okay.
And, I've got mostly condensers because I can fix it in the mix. My nicest one right here is $300. I won't tell you what my most expensive one is. It's not here and it won't ever be here. But I have some decent mics. And there are some that are purpose-built for different things.
Right.
That I have as well.
You sound much better today than you did yesterday when I was talking with you.
Yeah, well, because I was on my
amateur ear.
Because I was on this cheap piece of junky plastic.
What mic are you using today?
This is the Rode S1.
Are you using any compression with it?
I'm using nothing.
Nothing.
It's a flat EQ. There's nothing there.
So tell me about EQ. How does EQ affect what we're talking about?
Well, it's a badly named principle for a really good tool.
Okay.
When you've got a sound source that's coming in that has excessive sound in one area and not enough in another.
Okay.
Well, we'll just talk about the single, simple one microphone to start with, okay?
Good.
So say I'm really heavy bass and I'm just blowing you away.
Yes.
And you want to fix that at the board because you think this is ridiculous. I need to. So you go to your bass frequencies, which are the low end of the scale,
Right.
and you turn a knob, and the bass that's coming out of here goes down and becomes quieter
It just turns down the volume
But-
on one particular frequency.
on one particular frequency or set of frequencies. Yeah.
Okay. Okay. I'm liking this. I can understand this. This is good.
Okay.
So it's just a volume control. So if I have 10 EQ knobs, I've got 10 different volume controls, and I can slice and dice my audio signal and adjust the volume of any particular part of it up or down.
Yep.
Now,
You need to
ahead.
know what the frequency is. Okay.
my ear doesn't
And
tell me
remember-
that
Well, to a point.
to a point.
But the frequency will tell you, your ear will tell you what the frequency is, but it won't tell you the number.
Unless I'm really good.
The mixer will tell you the number, but it won't tell you this is the tone you're hearing. You just have to figure that out for yourself.
Uh-huh.
So how do you do that? Well, I use, because I'm usually dealing with musicians, I just use the musical scale. The A note at middle C, every musician knows, is 440 hertz. That's a magical tuning number that everything else is based on.
Right.
And when you go from that A down an octave is always divided by 2. So it's 220. And the A below that is 110. Then 55. And then 27.5. Going the other way from 440, it's 880 and so on up the scale.
Okay. I'm going to put a
So you
scale
could-
up on the screen.
So you can always know, okay, there you go.
That's your audio right now in vMix. And I've got
Okay,
2,
so-
4, 6, 8, 10 different volume knobs for different frequencies in that.
Okay, so they're not using the 440 scale that we were talking about.
No.
Okay, they're starting at around 500.
Right?
I don't know why audio mixers always do that, but those are fairly standard numbers. Okay.
Okay. So 500 is a good 500, 1,000, 2,000, 4,000, 8,000, 16,000. That's the same
So you
kind of
can
doubling effect that you're talking about.
Yeah, each one of those bars is only responsible for a whole octave.
Okay.
Your typical sound system graphic equalizer is going to be 31 bands, and it is responsible then for not one octave, but a third of an octave each band. Go ahead and kill that. You're going to start hearing my voice go away, and you're just going to have the upper end of this frequency band. See, there it is some more, and oh, now I'm really starting to squeal. Put it back.
That was awful.
All right. Yeah, that was horrible, but articulate enough. People understand what you did there. Now bring the high ends down. This is often done sometimes just for nice effect. All right. So, and when you push the 125 and the 62, now I'm going to sound profoundly bold and ballsy to everybody. And 250 and so on. This is, you can do a lot to change the character of the sound with it, with just the graphic equalizer and just a crude one like this. I mean, this isn't wrong. It's just you're affecting a whole lot of sound with each bar.
But it's fairly rudimentary. So that was 10, and I have a pretty wide slice of signal that I'm adjusting with each one of those 10. If I had 31, I would be adjusting a slimmer band of frequency with each one.
Exactly.
Okay.
Now, I'm going to tell you another characteristic that you probably don't know about.
I can guarantee you I don't know it.
Well, even some of the folks on the channel won't know it, is that when you're pushing a frequency up, the wider you can get your band, the nicer it's going to sound. when you get really narrow bands and you push them up, they start to howl and squeal and get all kinds of crap in the sound. Harmonic frequencies going off.
Right.
So the rule in my world that I use is whenever I can, I'm going to take those frequencies and I'm going to cut a bunch of them rather than pushing one up. But with this EQ setup, it's wide enough now, I'm doing a whole octave band, that I might be able to get away with pushing it up and not have it be really crappy sound. So there's a good reason for the guys who designed this to have done exactly what they did. And I applaud that.
Gotcha.
It makes it easier for guys like you who might not know.
Oh, yeah. And there's no might not to it. I mean, in audio, I've got to really stretch to be a neophyte.
Well, that's okay.
All right, so we talked a little bit about EQ and frequency. Let's talk about compression and what does compression relate to that, or is that just a whole different ball? And while we talk about it, I'm going to bring up the same thing.
I want to finish. I want to finish with.
You want to finish with EQ.
With an EQ that you don't have here.
Okay.
There's another EQ type called a parametric EQ, which was invented by a great Canadian. Called a parametric. You can adjust.
I'm just teasing. Keep going.
You get sick and tired of me talking about Canadians by the time this is done.
No. Some of my best friends are Canadians.
Yeah, well, so was Alexander Graham Bell, and
Right.
There's a lot of great audio guys from Canada. So the parametric EQ, usually on a mixer you get 4 of them, and you can adjust the bandwidth. The bandwidth parameter is something called Q, and It's ugly to understand Q. But basically, the wider it is, the smaller the Q number is, and the narrow the filter is, the tighter the band is.
Okay.
Kind of upside down thinking.
Okay.
You can think of it as division if you want to give you an idea.
All right.
Okay. And there again, the same principles apply. You can increase, you can decrease. It is all up to you. The other parameter, I was just looking in the chat, somebody said, didn't Alexander Bell not actually invent the telephone? I think he did.
Don't pay any attention. That's one of the Brits.
I'm gonna stop looking there. I'm gonna turn it off. In fact, so I can
wait till they start telling you things like your fly's down, and they'll put it all in caps like 10 different times. Oh, or you have no audio. Well, of course I have audio. I know that.
Okay. Where was I?
Okay, we were transitioning into talking about compression.
Oh yeah. Well, no, I wanted to finish up with one other thought too.
Okay.
Along with those parametrics that will allow you to adjust the bandwidth, there's one that kind of does this or this.
Okay.
Okay. So it's a gain or a cut, and then followed by something flat that goes to infinity. Okay. Those are high cuts and low cuts.
All right.
Those are also available on your typical digital mixer or digital audio workstation software or whatever.
Okay.
vMix isn't providing those, and I don't blame them for not doing it, because that's for musicians more.
Right.
Okay. Right. Let's talk about compression.
Oh, let's talk about compression.
You want to talk about compression?
I do.
Well, what kind of compression do you want to talk about?
Well, I want to bring up the vMix compression because I'm using compression on you. You didn't know that.
Well, that's good. Well,
but I'm not.
I guessed it, but good. Because I know you're excited about compression.
I am. I'm thrilled. This is compression in vMix, and this is your mic, which is being picked up in Skype and passed through virtual audio cables into vMix. So it's supposedly a lossless kind of transport. And so I've got you at a 5-to-1 ratio and a -10 threshold.
Okay, so In my terminology, I call that lopping.
Aha.
That's a lopping compressor.
That's a
And
lopping compressor.
what it's doing is it's taking my really loud stuff and knocking it down a bit. You
Aha.
remember in the good old days of audio tape, and they always used to talk about tape saturation? When you get to the top end of the dynamic range of the tape, it starts to compress for you
Okay.
because there's only so many magnetic little bits that would encode an audio signal, and you push it really hard and it just does a little bit more.
Okay.
That's the kind of compression you've got going right there
All right.
on a 5-to-1. Okay. There's another kind of compression you can do, which is basically saying, oh, this guy's range is a bit crazy. And we're doing a really loud production, so we want to lean into his audio a little bit.
All right.
So your ratio in that case would be like 2-to-1 or a little less. And your threshold would be right at the bottom.
All right. Which way's bottom? Left or right?
Well, uh, keep going. Way down there. So I can be relatively quiet and it's still good. And I can get quite a bit louder and it's still sane. But you're not getting the same amount of volume gain what I'm producing. You're getting roughly half that. Let's go up to the other extreme here. Put the threshold way up at the top, -5 or something. Good enough. Now let's take the ratio and crank it.
Crank
Go to
it.
20-to-1.
Ooh.
20-to-1.
Okay.
See, now here, what I'm doing is I'm stopping the audio from clipping. My audio signal can come in and be really strong, but we get to a point where basically it gets almost completely cut off at 20-to-1, but you're getting my full natural sound. That's limiting.
Okay.
Okay. So you're
Okay.
giving yourself a ceiling that's below the technical digital limit where things start to sound really ugly, because digital clipping sounds really horrible because it's really, really efficient. And when it comes to clipping, you don't want efficiency. So lean, lop, and limit. There you go. That's it. Other controls you will see on digital mixers and other places, you'll see something called attack.
Right.
Okay. In any scenario where you're doing what we're doing here, which is non-musical, you want that to be 0. Just
Okay.
nothing. Gone.
All right. So what's the attack in this scenario right here? We can't tell.
They didn't give it to you, and when it's gone, you can assume it's 0.
Okay.
Because if it wasn't 0, every time I started to talk from being silent, you would hear the complete highest volume of my sound.
Okay.
You set so this is a trick we use in audio all the time. We got an organ playing, and it's playing sort of mid between the sound bed and the chorus that's way at the top. And we want it to punch through a little bit, but organ sounds don't have that initial click like a guitar will, or a piano. Then ding. Well, the is the sustain and the d is the click. And when you want one of those clicks and you don't have it, you open the attack to say around 20 milliseconds, and you use a fair bit of compression. When you do that, the compression creates the sustain sound, and what you left open with the attack creates the hit. This is also done quite a bit with bass guitar and other places. Now, in bass guitar, I'll tell you a secret. If you guys are ever mixing for somebody live and they sound really bad on bass guitar, use the 0 compressor and just squish to squish it 8-1 and turn it up just loud enough so you can hear it. And all of that guy's playing, he's with the bass guy, with the drums or not with the drums, it won't matter because the drums are going to be taken over and being in control. So
right.
that's a trick to fix somebody who's really bad as a bass player. And the other way, going the other way to the other extreme, is how you make it sound really great for somebody who's really, really good.
Okay, now let's go back to human voice, because a lot of us are working primarily with voice and not with instruments.
So let me talk one more about those three kinds of compression.
Okay.
For dummies, for guys who don't get it and just want
idiots.
to turn one knob and have it work.
Yeah.
There's a compressor out there called a really nice compressor, RNC.
RNC, really, really nice compressor. I got it. Okay, good.
Okay. It's about $250.
Yeah.
It doesn't have XLRI ins and outs. It's just standard quarter-inch cable, I think, or RCA. Okay. I can't remember. And it is stereo. So you get your stereo signal in and you get a stereo signal out, and it does that lean, lop, and limit. And it's very nicely coordinated for people who don't know how much lean versus how much lop versus how much limit.
Right.
So it's all pre-programmed in there to work really well. And the nicer thing about that kind of compression is that you don't actually overuse any one of those three to compensate for the missing piece in the puzzle. Mm-hmm. That's a really useful tool. It's a niche tool. You won't hear too many people talk about it, but I really love that thing.
Oh, I bet you do. And I bet I wouldn't know what to do with it.
You put it in your signal chain and you turn the knob till it sounds good.
Well, that I could do.
Well, yeah.
I
mean,
could do.
That's actually the essence of learning how to do audio all the way around.
Is to have the ear. Yeah.
It's always to have the ear.
But once you've got the ear,
but
Michael, once you've got the ear, you've got to understand how the individual tools work to make what you hear translate into what you want it to sound like. And I'm beginning to get that now. So you're saying, okay, well, you've got got compression that will do this kind of thing. We're gonna do different kinds of things with compression. We're gonna do different kinds of things with EQ. But let's dumb it down and say, okay, I've got somebody, and all right, let me pitch you a scenario, and you tell me how you'd fix it. Okay.
Okay. Right.
All right.
We'll start with what you want to do.
Yeah, yeah, it is my show. Let's say you've got somebody that they talk like this a lot because they're a shock jock. And then they also get really, really quiet. And I bet the audio guy is going nuts. How in the world do you deal with those kind of extremes?
Well, and he whispers from the back of the room and he yells at the mic. So
yeah. Yeah, how do you fix that?
Well, compression.
I thought compression just squeezed things.
Well, it does.
All right.
It creates a smaller dynamic range.
All right. Well, show me. I'll do the adjustments, but you show me in vMix how we would do. I'm going to reset everything here. I'll turn the compression off.
Okay. So in this scenario, I would be more inclined to go towards a ratio of, say, somewhere in 5-1 where you were doing that lopping. Okay.
All right.
And then as I'm getting crazy loud and you don't want it that loud, you tell me, okay, bring the threshold down till it sounds all right. Well, is this good or what? Where are we getting to the point where it sounds all right? Now, as I whisper back here, where is it loud enough? That's all there is. In some mixers, in some scenarios, you can get, and I would encourage the guys at vMix here to put this in. You can push the threshold way down to the bottom, but there's something called makeup gain, which allows you to bring up the volume of everything together.
Right, right.
And that's really helpful, and they don't have that.
Well, now hold on. Let me go back to something, and you tell me if this would be the same. Can I just take the gain right here and move it up?
Yeah. Mm-hmm.
Okay.
Yeah.
And so now I've amplified that compressed signal.
First of all, go and compress the crap out of it.
Compress the crap out of it. Okay.
Yeah. So going, heavy threshold and heavy ratio till it's not really good enough. Like 100 dB is too far. Let's go down to, 70 or something.
Okay.
Okay, 12 to 1 compression. Now, if you say this isn't loud enough coming out, see the pre on the left is me and my mic. The green on the right, that's what's after the compressor.
Right.
But let's say you needed it to come up a bit and be a little louder. Then you can go back to your general and boost it up some. And there you can see it starting to come up, and you're getting to -12 and so on. So what do you want to talk about?
All right. So now that I've limited you, I haven't limited you. I've compressed you using ratio and threshold, and then since the volume was too low, I've bumped up the volume by putting the gain up to 16 decibels.
Right.
So I've got you at the volume that I want, but you can scream all you want to, and screaming won't make any difference.
Let's try it out. How's this? Can you hear me?
Yeah, but it was about the same level. It just was a little crackly at the top, I guess.
Well, yeah, that's probably because something in the signal chain clipped.
Yeah.
Probably my end, not yours. Look at that button over there underneath the reset.
Underneath the reset.
Automatic gain control.
Yeah.
Automatic gain control is a fun little toy that will automatically adjust the level depending on where I sit with the mic, and it's got a bit of a time constant to it, so it won't react instantly, but it reacts over, say, a half second or a second to kind of calm things down and level things out over time. That's what that's for.
I'm going to turn it back off. Should I have my gain set all the way down to 0 when I turn that on? Or will it make any difference?
I don't know. It depends on how it was implemented, but this sounds all right, eh?
Yeah, and that's what the gain set is 0. Okay.
So if you turn it on and it sounds good and it's not clipping or making a whole lot of problems for you, go for it. Leave it there.
Okay. All right. Let's go back to compression for just a second. So we're going to go back to the compression here. And I've got two different things that I'm working with. I've got ratio and threshold.
Right.
Ratio and threshold. Tell me, a minute ago when I gave you the scenario of a really loud talker and a really soft talker, you just picked out of your head the numbers on ratio and threshold. How did you know what numbers to work with?
Well, it's history, but it also has to do with those angles I was telling you about.
Okay.
That's my threshold. That's where it starts to come in.
All right.
When I'm lopping, that's where it starts to come in. And when I'm limiting, that's where it starts to come in.
Now, when you say come in, you're talking about a decibel level?
The dB level where the compressor starts to work.
Okay.
And the angle is the ratio. Think of it like a mirror.
Okay.
Think of it like a straight 45-degree angle is like a mirror, okay? It comes up, it comes out.
Yep.
The coming up is your audio signal at the source.
Right.
You're going out is the audio signal that you're distributing.
Okay.
If I'm leaning in, first of all, there's a lot of stuff that might not even get hit by this thing.
Sure.
It might just go out, all right?
But when it hits what decibel level what ratio would that be if it was just a little bit? Would that be a low ratio, like 2 to 1?
Or under.
Or under. Okay. So the more it tilts over, the higher the ratio would get.
That's correct.
Okay, all the way up
So
to
20 to 1 is like this. Or if you use a low ratio, 20 to 1 it looks like that. You know, it's squishing the sound is what we usually say.
okay.
And this is relating the input to the output. Squished way down, you could have a really loud input to a really not very loud output. That's how the graph works.
All right. So what does the first number represent? And what does the second number represent?
The first number is see the level where you got pre
Yes.
and you got the meter going. Okay.
Yes.
That's your input. That's the bottom coming
Okay.
up. And the output, that's the post. Now you're going to get some guys, maybe even on the chat right now, and some other pros who have been around a while and say, "Well, Michael, you're just simplifying things too much. There's all kinds of other things going on here. There's RMS versus peak, and there's this and that. And the other. I know all that stuff. You don't need to know that.
Right.
The different compressors will have different characteristics, and generally you want to avoid the cheap ones, like $120 or something, if you're buying a standalone unit.
Uh-huh.
$250 usually doesn't get you much of a compressor either, and the RNC is an exception to that rule.
Okay.
Because some history that these guys actually started building the RNC as a bit of a hobby project that they were teaching people electronics with.
Right.
And it turned out to be so popular they turned it into a product, but they never wanted to sell it for what the industry calls the right price. The right price for that compressor, by the way, would be around $2,000.
Uh-huh. Uh-huh.
I'll take it, thanks. But anybody else producing the similar product would charge that kind of money. So,
Gotcha.
where did you want to go next?
RNC. Well, we have grossly overstayed our welcome. We are 26 minutes over time. So the show is almost twice as long as it was supposed to be, and it's just gone by so quickly. What I suggest is right now we end the show. We go to pre-show. We take some questions from the chat room, and the chat room I think can also give us some direction on where they would like to see us go next time when I have you back on the show next time. Can we do that?
Absolutely, sure.
Okay. All right.
It's been a lot of fun. I feel like I scratched my belly a little. I didn't even start.
I know the feeling. It's like, where did 6 hours go? Holy cow. All right. So we're gonna send Michael into muted purgatory, and we're gonna shut down this section of the show. But suffice to say, Michael's knowledge of audio exceeds mine just barely. And we're going to have him back on the show again in the future. And as you could tell, it took us a little while to get into the really good stuff, and I think we can start at that point next time. But I really do appreciate you guys showing up today. Those of you that are live, those of you that are watching us later after the fact, I appreciate that. If I can help you in any way with live streaming, shoot me an email, tom@easternshorebroadcasting.com. Just a calendar note, we're not going to have a show the week of Thanksgiving, so there won't be a show Wednesday in 2 weeks, but we will have one next week, and we will have one the week after Thanksgiving. But I do appreciate you guys being here for this show, and if you're watching live, stick around in chat, and we'll pepper Michael with some questions and see if we can't stump him, maybe, huh? So, golly gee, I'll see you next week. Thanks for coming.